Hello, everybody, and welcome to another episode of Analytics Mindset. In this video, we will be going over the basics of data frames and how to filter them with Pandas. This is a follow-up to my programming basics video. In case that you have not seen it, please go and give it some time, because we will be going through a lot of the material covered in that video. And I will just assume that you already are either familiar with it or went through that video beforehand. With that being said, let's start. I will start by importing two important packages here, Pandas and NumPy. I'm importing Pandas as PD and NumPy as NP. As a reminder, you could just import them as whatever you want to, but I prefer to do them like that because I'm used to it already. We can create data frames in a lot of ways. The first one that we're going to explore is using a dictionary. That is another Python data structure that we could discuss it for a lot of time. That we'll have some video at some point. For now, what you need to know here is that I'm creating a dictionary that I'm calling DC, and I'm opening curly brackets to assign to places these three cities' names. This is a list: Albuquerque, Phoenix, and Montreal, and I am assigning the rank 2, 3, and 1. This is just made up data. Do not worry about the meaning of it. I am just using it for demonstration purposes. Now you can see here in the console, this assigned this dictionary to DC, and in the variable explorer, if we double click here, we can see the structure of the data. We have these two keys, they are lists, they have size 3, and the values are here. Now, in case you are wondering, if you don't have an IDE, you could always just use print. You don't have this, you still want to see the structure more or less, you can just execute this command of print, and here you can see how the keys are organized here. Now we can create a data frame using PD for Pandas. It's coming from Pandas here, that data frame, and then our dictionary here. What this is gonna cause is that our dictionary is going to become a data frame. You can see the difference here if I open this side by side. This is the structure of a data frame. It has an index, and it has my two columns here. Now you can see the data types of the columns if I open it again. However, Python inferred the data types from the list. So that's why you can see here that Albuquerque, Phoenix, and Montreal are like this because they are text, while the rank is an actual number. But we can also understand data types better if we actually just see them instead of just inferring them from that output. We can take these D types, and what D types is going to do is going to take the data frame and give us what is the data type of that specific column. Here you have places that it identifies as an object or a string, and then you have the rank that is an integer 64. That is how you know that places is a string and rank is an integer. And again, this is also more useful if you go in a command line environment, because in that case, you do not really have a variable explorer or the console here showing that output. You will only have this text here in the console. So that is pretty important to know. You want to be able to see through different ways information of the data frame. Also notice how it says the type object. This is the data type of the whole data frame, and it identifies it as an object because that's anything that Python says is more complicated than a string. Again, we can double check it looking at the variable explorer, but we can also do a lot of other things like visualizing the data frame in the console. For this, we can also just print the data frame. That is probably one of the fastest ways to see how the data frame looks like. And again, compare the dictionary to a data frame. The data frame is in the format that you would expect from tabular data, that we will go here into a second. Now, if we want to extract only the columns of the data frame, we can see them using these columns. We can take this, and by using columns, you can get an index that says places, rank, and what is the D type of it, an object. You can also look at the dimension of the data frame, also known as its shape. How big is the data frame? And again, we get it here in the variable explorer, but in case you need to play with it, you can actually do this. And here you can see you have first data frame shape, and then you get the shape. This has the records and the columns. You only have 2 columns with 3 records each one. We can even do something else because this is just a list. And if we put 0, that gives us the first value here. The first value in this list will be 3. What is 3? Is the number of records. If you only need to know the number of records, you could use that to get it and then pass it somewhere else. We can also just get the number of columns instead. So if we take this and make it a 1, you can get the number of columns here. It has 2 columns. We can get the index of the data frame. I will not go that much into detail about what is an index. It is actually quite complicated sometimes. But think about it as a row label. You can see here how there's a 0 for Albuquerque, a 1 for Phoenix, and a 2 for Montreal. If you paste this, you can see how it says rate index. It starts at 0, that's where it starts. It stops at 3, and it has steps 1. So this has an index from 0 to 2, and it's in steps of 1. So there is no half index anywhere to be seen. Now we can go back to the NumPy representation if we want to, by just taking the values of it. Here you can see I have Albuquerque, Phoenix, and Montreal, and I have each of them assigned here. It is the same information, it's just a very different format. And that's actually quite a bit of a problem sometimes. Sometimes you will need to double check that you're working with an actual data frame, or if it's just a dictionary that you need to convert into a data frame, or vice versa. We can just get the items by iteration too if we use items instead. Here you can see we got places and rank. Not the best format ever, but you can see here Albuquerque is 2nd, Phoenix is 3, 3rd, and Montreal is 1st. Now, NumPy arrays are all the data structure that you can use to create data frames. And we are going to create a data frame that has more columns than the other one that we just saw here. We are going to use NP array. We are taking from NumPy the array here, and we are constructing an array that's going to have these dimensions, and we're going to call that data. Now we go to data here. You can see how this array is just 1, 3, 4, 5, 6, 6. There is not really a lot of meaning behind it. We have 2 different lists, each following each other. We have this in 2 lists stored over here, 1 list here, and then we can use a second data frame. The syntax is a little bit different this time around. We're using still PD data frame with data, but then we're assigning columns. We are saying the columns for these are X, Y, and Z. If you take this and paste it here, if you look at here, now you can see how this became X, Y, and Z. So we have the columns here, and we have the values here. Now compare that to the actual array beforehand. It is exactly the same data, but it is just in a different format. In this one, we don't have columns. It's just a representation of an array. How you could understand this is this becomes the first row for each of those records, and this becomes the second row. It basically puts them below them, and then it assigns these columns here. If that did not make sense, please go back and watch that again. But this became the first row, and this became the second row. Now, the final way that we will explore here is using a Pandas series. Pandas series is another data structure in Python where we're going to create a series called 1, 2, and 3, and the index is going to be 1, 2, and 3. Not a lot of mystery there. We just call it series, as you can see here, it has an index, and it has 0 here, 1, 2, 3, because it's a series. Now we can print that as well. Here you can see index 1 is 1, index 2 is 2, index 3 is 3, and it's an object because those are strings. Now we can convert it to a data frame. We are going to use first column as the name of a new column as we did beforehand here. in where we assign these letters here. However, because we only have one column, we will do this. We take Pandas data frame, we take the series, and then we take the columns. The columns are gonna be named first column. And if we go to the Variable Explorer again, we can see here, now we have the name first column and the index here, and it's a data frame. And we can print this as well. We have 3 data frames and their structures, and we can do a lot of things with them. But first, we're going to use the log attribute. Log allows us to retrieve a specific row, such as the first one. Remember that on Python, the index usually starts at 0. Therefore, if I do this, what I am saying here is from the first data frame, return me the location of the first row. And the first row is Albuquerque with a rank 2. We can do the second row too. That again will be by 1. If you do not want to do this and you would like to do something different instead, we could do it, but we are going to just go ahead and keep going with this. Remember that you could actually just do your own function, or you can do a function that grabs log saying, if this starts at 0, make it 1, 1, make it 2, etc. But that's just a complication for another day. For now, we will just stick around with the current method, that is log. Just think about adding 1. So this is the first row, this is the second one. We can also use log to return multiple rows instead of passing one value at a time. In Python, something I do want to say is sometimes you have a number like 1, 3, 4, 5, etc. But we can also use this. 1, 2, 3. In this case, it's returning me an error, but see what happens if I put it here. If I put it inside the log function, it will return me values for both 1 and 2, actually. And now the following syntax is the same. Instead of using this, you could just say, okay, never mind, give me 1 and 2 separately. We can do that as well. And we can also filter the data frame based on a condition. So we can actually say, I'm going a little bit more refined here by first data frame. Let me look at that again. You can see here we have 3 places and rank. Now, what if I give you this data frame and I want you to give me only Phoenix? This is the most basic way to do it. You take first the value of the data frame itself, and then you're filtering it by a Boolean list that compares each of those rows with the value that you want to get. And I know that sounded very complicated, so we're going to go step by step. We have first data frame here, where you're getting your places and your ranks. Now, we can extract the column, and I will go more into detail about this later, by naming it here. This only gives you that column instead of the whole data frame. I'm not getting the whole data frame, I'm just getting this column. That is the places column. Then I am saying, tell me where this is equal to Phoenix. And if I do that here, you will see that the first one is false because that is not equal to Phoenix. The second one is true. And the third one is also false because that's, again, not equal to Phoenix. Then we can add another layer of complexity. We have this condition here. We can use the Boolean list that we got here to filter the original data frame. And that's how we get the actual row that belongs to Phoenix. So what we did here again is just first take the data frame column that we want to filter by, compare it to the value that we want to filter by, and then use that to filter the original data frame. I know this syntax looks intimidating at first, but it makes sense if you look into it a little bit longer. One more time, you have your column here, then you compare that column to the value that you want to get, and then you compare that to the original data frame. That is basically the same as the word clause in SQL. Now we can do the opposite, actually. Instead of getting the records where the city is Phoenix, we can get where the city is not Phoenix. We are negating the condition. Take this again. And this gives us the Boolean list that's going to filter our data frame. Instead of using equals, we're going to say is not equal, that is represented by the exclamation mark. Here you can see it's the opposite. This is true, this is false because this is equal to Phoenix, and this is true. And we can just use that to filter the original data frame again. Here you have your places and your rank, and here we have the two cities that are not equal to Phoenix. Now, there is a lot of ways to do this. We could do it with ilog, with log, etc. But one of the most intuitive ways that some kind of hides the complexity behind it is the query function. So we can just use query. And pretty similarly to what we did before, is taking the first data frame, then the function query, and it's saying places needs to be equal to Phoenix. And that is what you're going to give me. And we can do the opposite. We can negate that condition. Remember, by negating the condition, you're saying, give me what is not equal to that. And that gives me the other two places that I want. Now, one more detail that I want to give you is we have been looking a lot into how to filter specific values of a data frame. Think of a data frame as an Excel spreadsheet. If you're more familiar with Excel spreadsheets, that is fine. You're going to actually find it very similar. It is a rectangular tabular data where you can not only get a specific row, but you can also get a specific column. One way to do this is, remember second data frame here. This has 3 rows, X, Y, and Z. What if we want to get X? We can just say second data frame dot X. If we do that, you're going to get X, 1, and 3. Those are the values of X. We can also get the same value of X by just using square brackets and putting that as a string. We got exactly the same thing, 1 and 3, and these two are exactly the same. Now, I will wrap up this video by saying this is just the basics of data frames. Merging, joining, and grouping data frames and concatenating them are outside of the scope of this video. We will explore them eventually, but for now, we are just doing this to get the basics of data frames. And with that, I really hope this was useful to you. If you liked it, please give me a like, a comment. I will appreciate your feedback. And as always, take care. Thank you.